5.1. How do I use function notation? All right, so our vocab for today is function notation. Again, don't forget to write your own example and your own words of our definition. Okay, so function notation is another name for y. It is the value of the function f at x equals. So basically the number on the letter on the outside is the name. So this is function f, and the number inside is the input. So in this case, we're using an input variable of x. So it tells me what number I'm plugging into my equation. Okay. Together, these two things, f of x, mean y. Y at x equals something. Okay. The second one, the name of the function is h. What is the input of the function h? Well, I'm going to use the variable x. Okay, is the input. Together, this whole thing is equal to y, the output. Okay, we're going to work on an example here. Okay, so I see that I already started this one. All right, we're going to start with g of 5, and I would like to solve for either an input or an output. So I'm going to look. G of 5 is, we need to use the function g of x is equal to negative x plus 3. So I'm going to write it here. G of x is equal to negative x plus 3. We're going to use that in a second. Okay. So I'm either going to be solving for x or y. I just don't know which one yet. I can see that g of 5. So that number inside the parentheses, remember, is the x value. So I already have the input. So I'm not solving for the input, I'm solving for the output. I'm solving for the output when x is equal to 5. Okay, so the way we calculate this is we put in, anywhere there's an x, we're going to put in a 5. So I do g of 5 is equal to negative, instead of an x, we're going to put a 5 plus 3. Okay, I'm going to bring down my g of 5. See, negative 1 times 5 is negative 5 plus 3. So I get negative 5 plus 3 is negative 2. So g of 5 is equal to negative 2. What this means is that when x is 5, the corresponding y value, or the output, is negative 2. That's our y value. That means that the point 5 comma negative 2 is on our function, or is on the line. Okay, so right here, we're going to make sure that in function notation, the answer always has this set of parentheses right here. Okay, always has this set of parentheses. Okay, and it's the value of x that we evaluated. Okay, next up, we have g of 10. G of x is equal to 10. So x, the 10, is that our x or our y? Well, because the x isn't filled in, the 10 has to be the y. So we know the y value is 10, but I have no idea what the input value is. So we're solving for x. So what we do is we write the function g of x is equal to negative x plus 3. And for the g of x, which is just y, remember g of x is just y, we're going to put in the value 10. Then we bring everything else down, negative x plus 3. All right, so we're going to continue to solve the equation. So subtract 3 from both sides, giving us 7 is equal to negative x. And really there's an invisible 1 in front of the x, so we're going to divide by negative 1. Leaving us with negative 1 divided by negative 1 gives me a positive 1. So 1x is equal to negative 7. So this means that we have an ordered pair of when x, or actually let's write this as g of negative 7 is equal to 10. Again, the nice thing about function notation is that the number inside the parentheses, it tells us what x value we plugged in. to our function, okay? And then we got out a y value of 10. So the x value is -7, and the corresponding y value gave us when I plug in -7, I get an answer of 10, which means that the point -7, 10 is on our function, okay? Okay, sweet. Next part, from a table, how do we do this? So we're going to use this table given. I'm going to evaluate when f of 7 is equal to, when f of x is equal to 7. So is 7 the input or the output? Well, basically, if there's an x inside the parentheses, you're solving for the x. Okay, so 7 is the y, and we don't know what the x is. So we're going to solve for the input. We know what the output is. It's 7. Okay, so I need to look at the table. Which of these lines is the x the input, or the f of x is at the input? Okay, the input is the x, the y is the output. So I'm going to go on the output to 7. Then what is the coordinating input? It's 1. So when the x value is 1, the y value is 7, which means the point 1 comma 7 is on the function. We write this in function notation as f of 1 is equal to 7. Again, that's our x value and our y value. Okay, you try the next one. The next one, we're looking at the input of 2 is x. Okay, so I know the input. I want to find the coordinating y value. So I'm going to write on the side, f of 2 is equal to, and we're going to fill that in. So I look at the table. When x, our input is 2, our output is 9. Okay, x and y. So we have 2. When x is 2, the corresponding y value is 9, and this means that the point 2 comma 9 is on the function. All right, we're going to do this again using a graph. So I want to figure out f of what is equal to 7. So f of what is equal to 7? Is the 7 the input or the output? The 7 is the y, which is the output. So I know the output. I will be solving for the input. Okay. So on the y-axis here, I'm going to go to 7. Let's see, 1, 2, 3, 4, 5, 6, 7. I'm going to go over to where it crosses the given line and then draw down. This is the point 1. When x is equal to 1, I have an output of 7. So I'm going to write f of 1 is equal to 7. Okay. When the x value is 1, the corresponding y value is 7. So that means that the point 1 comma 7 is on the function. And really the line here, remember, is the function. So it's the point on the function? Yes, it is. All right, you do the next one. Okay, I have f of -2 is equal to, so what is -2? That's our x value. We know our x value. We are solving for the y value. Okay, so at -2, 1, 2, so on the x-axis at -1, 2, I'm going to go up to where the line crosses the vertical line at -2, and I see that's a value of 1. So when the x value is -2, the y value is 1. Okay, so when the x value is -2, the y value is 1, which means that the point -2, 1 is on the function. I have a situation for you. The function c of x, oh look, we can call it whatever we want. C of x is equal to 3.5x minus 2. And it represents the cost in dollars of buying X tickets to the orchestra with a $2, and you have a $2 coupon. Okay, so I saved $2 basically. And then after that, each ticket costs X dollars. Oh, no. Sorry. What we don't know is how many tickets we bought. We know the cost. The cost is represented by this function here. Okay, so C is going to represent the cost, and X is the number of tickets we buy. Okay, C of X means the cost for that many tickets. Okay, so first we're going to go ahead and look at our example. How much does it cost to buy 5 tickets? So I'm going to go C of X is equal to 3.5x minus 2. Now, I know there's 5 tickets, which is the X value. And I'm trying to find out the C value. Okay, so I'm going to write C of 5, the cost of 5 tickets is equal to 3.5 times 5 minus 2. We're going to get C of 5 is equal to 17.5, so multiply first, and then subtract 2 for the $2 coupon. Okay, and we get C of 5 is equal to 17 minus 2 would be 15.5 or $15.50. So the cost of 5 tickets is $15.50. All right, we have the graph of the function C of X is equal to 3.5x minus 2. We're going to label the independent variable and then the dependent variable. The independent variable is the X. That is, X is equal to the number of tickets. The dependent variable, Y, is equal to the cost of the number of tickets. All right, then we're going to go ahead and, we don't really have parts A and B, but we can definitely graph from this point here. This is what I want you to do. So C of 5 is equal to 1550. Oh, you can't see because my face is in the way. I'm sorry. Okay, so here we go. C of 5 is equal to 1550. So if X is the number of tickets, I'm going to go to 5 on the X-axis right here. I'm going to draw up, and I'm going to see the Y value is 1550. This is the point 5, comma, 1550. If it wasn't, then I did something funny in my first example here. Okay. All right. Up next is how many tickets can you buy with $19? And we're going to show this work algebraically, and then I'll show you on the graph. Okay. So we're going to start with C of X is equal to 3.5x minus 2. That was our function. Is 19 a cost or the number of tickets you bought? This is the cost. So it's going to replace the C of X. Okay. So $19 is the total, is equal to 3.5x minus 2. Now we're solving for this X value because we want to know how many tickets can we buy, did we purchase to equal $19. I'm going to add 2 to both sides to solve for X. So I get $21 is equal to 3.5x. So I forgot a step. How do you get X by itself? 3.5 is multiplying with X, so we're going to divide by 3.5, and I get X is equal to 6. So X is equal to 6 tickets. Another way to write this would be C of 6 is equal to $19. Another way to represent this information would be 6, comma 19. Let's look at our graph and see if there's a 0.6, comma 19 on our graph. Okay, so I'm going to go over to 6 right here. I'm going to draw up to 6, comma 19. Yes, it's a point on our graph. We know we did this one right. Okay, don't forget to fill out your vocab and then to work on your summary.